everyone. Welcome to the Carolina Weather Group. This is the Wednesday, October 2nd, 2019 edition of our little weather get-together. This is show number 294, and tonight we have with us Chris DiVeglio. I probably pronounced that wrong, Chris. I apologize. We're going to be talking about meteotsunamis tonight, and something that you may have not heard about. Maybe you have. Two of our popular tourist destinations actually affected by these. So we're going to go in depth tonight and talk about that and talk about what causes these occurrences. So we welcome Chris to the show tonight. If you are watching tonight, you are probably watching right now on our YouTube page, our Facebook Live, Periscope, or Twitch page. We encourage you to interact with us tonight. You can ask a question, and all you got to do is type it out. We'll be monitoring those throughout the show. And if you have any questions for our guests or any questions related about the weather, send them our way, and we'll hope to answer those throughout the show tonight. If you are listening to the podcast version, which we highly recommend that you go to your favorite podcast outlet and download us and subscribe to us. We would love for you to do that. And we'll let Chris at the end of the show give out some information on how you can learn more about these. So great topic tonight, and we're really looking forward to it. We are going to talk a little bit about the heat and maybe when the heat starts to relax later on in the show. But before we get into the news part and the forecast part, let's bring in our guest tonight. Chris, welcome to the show.
Thank you so much for having me, Scotty. I appreciate it.
Yeah, we're excited to have you. So since you're a first-time guest, this is kind of a first-time guest question that we ask a lot of our guests who come in. How did you get caught up in this crazy world of weather that we are all dabbling in right now?
So like many of you, I was one of those that became interested in and fascinated really with the weather from a really young age. So I was someone that knew what I wanted to do from a really young age and kind of driving my siblings and my parents crazy and wanting to watch the weather and tracking all the storms when I was real little. So followed that path and went to school for meteorology up at Plymouth State University. It's up in New Hampshire. I come from following that an operational forecasting background, and now I'm on the government side of things, a little more oceanography focused, but it's been a lifelong passion of mine, and combining two things, weather and the oceans.
That's really cool, and we're excited to learn about this. Before we get into the topic, you said you worked in meteorology. Now you're more in the oceans. Anything that particularly led you in that direction, or just one thing led after another, and here you are?
Probably one thing led after another. I mean, again, since I was really young, I spent a lot of time at the beach. So, monitoring and watching the tides and currents was also something that I was interested in. And fortunately, the program office that I'm in now, within the National Ocean Service, we maintain all the tides and currents gauging all around the country. And most of our network has meteorological data associated with it. So, when I transitioned to that, I've had some involvement with meteorology research, but also data monitoring. I've been with the government for about 6 years now and bounced back and forth between data analysis of our water level data, but also real-time data monitoring of our tides, currents, and oceanographic and meteorological data. Now I oversee a program that sort of specializes in the focus of oceanographic and meteorological sensors concentrated in port areas, as that data is very valuable for supporting safe and efficient maritime commerce. So I've been quite a bit of experience, but I still love every minute of what I'm doing.
Very good. Well, I'm going to go ahead and jump right in and ask the topic for tonight, meteotsunamis. A lot of folks out there have never heard of this. Would you care to explain exactly what a meteotsunami is?
Yeah, so I'll start off by saying that they're different than seismically driven tsunamis. So meteotsunamis are atmospheric induced water waves, which they are generated by quick changes in air pressure, usually associated with fast moving weather systems. So, they have the water level response is similar frequency characteristics as seismic tsunamis, but obviously their forcing mechanisms are a lot different. Usually, when I talk about fast moving weather systems, usually a squall line summertime convection. We've had them, triggered even by a derecho, which has moved across the land and out over the open waters. But we also see them from winter storms as well, and even sometimes disguised within tropical systems as well. So and I'll get into this a little bit more, there's certain times of the year where we observe them a little more frequently than others.
Very good. And so we're talking a little bit about some of the weather phenomenon. What are sort of the some of the weather events that occur that would trigger some of these? I know we think of you said derechos earlier with thunderstorms. A lot of these storms are coming from west to east, but are there other factors out there that create higher water amounts, like nor'easters or even tropical systems?
There are, and the thing is a lot of times, folks. There's still a lot that's to be learned about meteotsunamis, but there's also been a lot of progress within research over the last couple of years. And a lot of times people don't realize with meteotsunamis, they can often be confused with wave run-up or your storm surge, which is obviously a gradual buildup of water over time. So there's a certain signal that you can see from a meteotsunami, and again, depending on where they're observed, where that tide station is situated, sometimes it's a little bit more difficult to pick out the signal too. Not just derechos, but even just a cluster of thunderstorms that may pop up or move along the coastline. That in itself is enough, if the conditions and the mechanisms are right, allows a generation of a meteotsunami.
Yeah, I totally agree. We have the Gulf Stream just off the coastline here, and that generates a lot of heavy thunderstorm activity. Even some of those storms, when we have a reversal of sort of the atmospheric flow, you'll see some of these storms moving into shore, and some of them can get pretty powerful.
Absolutely.
So I feel like we've only really started hearing about the meteotsunami research over the last 2 years or so. Is there perhaps one particular big event that kicked off this research?
So they've been documented globally for many, many years. I think what restarted, though, the interest and the focus was that June 2013 event that affected a good bit of the East Coast. The signal was captured everywhere from southern New England all the way down to the Carolinas and even beyond. So I think at that point, especially because it was a newsworthy event, Barnegat Inlet, New Jersey, there was a bunch of scuba divers. Once the initial wave came in, kind of dragged them up to the jetty, and there was some noticeable change there. There was also another area where it was observed that from that same storm system that triggered up in Falmouth, Massachusetts. That was a little bit more of an enclosed estuary area. But I think that particular event sort of reignited some of the interest in research and possibly also the need for a product by the Weather Service or other companies to for a warning system. But the issue is that because there hasn't been a whole lot known about them, and we're still learning to this day, I think that we haven't quite been able to get a solid product generated, if you will. But prior to that, there were global events. I mean, ones that caused death, if you will. I mean, back in the 1950s, I believe it was Lake Michigan, where there were 7 people that passed away, and there was reported up to a 3-meter high wave. In addition to that, Daytona Beach back in the early 90s, Booth Bay Harbor, I think it was in 2008, there was damage to boats and infrastructure there. And then there was another one in March of 1995 on the west coast of Florida that was observed from several areas, from Tampa down to Naples. So in addition to that, I can cite some global examples as well. But, so they've been around. They've been documented.
And how often do these occur? Is there a specific time of the year where we're more susceptible to see these? Yeah,
so I'm sure we'll talk a little bit about it, but my office, which is the program office that I'm in, the Center for Operational Oceanographic Products and Services, as I mentioned earlier, we monitor all the tides and currents data all around the country. So we're the federal authority for tide data. And, we spend a lot of time and research deciding, or time and effort thinking, hey, let's focus on a particular area, a particular region, and just see what sort of information we can deduce from our tide gauge data. So what we did for an article that we put together, and it's since been published, is looked at 22 years of tide gauge data along the entire East Coast. And from that particular research, which I'm happy to answer more questions on, we saw that the East Coast as a whole averaged about 25 events per year. Now, the events themselves, the size of the waves and the size of the impacts does vary. So, more than 90% of them triggered waves that were less than 1.5 feet. But there were some certain years, some noticeably larger sized waves that were observed.
All right. I think Scotty, were you did you want to ask about Myrtle Beach and South?
Yeah. I as always I forget to unmute my microphone. And the article that really piqued my interest and led me to reach out to you guys, Chris, was these occurrences that you're talking about, around 25. But it highlighted places like Myrtle Beach and Duck, North Carolina, observed the greatest number of these events, 184 or 148. And 130 respectively. And Wrightsville Beach also, Cape Hatteras also mentioned in those in the article as well. So kind of the North Carolina and portions of the Northeast South Carolina coastline. So any particular reason why those areas experience more, or what did your research lead into that?
Yeah, well, the straightforward answer for that is each of those stations that you referenced there, Scotty, are all in exposed locations. Those stations are situated on open pier. So I think that, coupled with some of the mechanisms where you have nor'easters that generally develop, or in most cases develop off the coast of the Carolinas in the wintertime, but also look at all the convective activity that happens in the summertime, from your run-of-the-mill thunderstorms to larger cold fronts. So I think that's one of the bigger reasons why some of those locations, not only that, but just the geography along the North Carolina coast and the bathymetry too. There's a lot of spots in North Carolina where you don't have to go too far off the coast. There's a pretty large increase in the bathymetry underwater, where it gets deeper fairly quickly. And I did want to back up to the previous question that was asked about, was there particular times of the year? As on the East Coast as a whole, looking at stations from Maine all the way down to South Florida, there were 2 times of the year that stuck out in particular. And again, one of those was the winter time, and the other was in the summertime. So there were noticeably more events at those times of the year.
So after, I think it was our show last week, we were all talking about, there were 28 horses that were killed in the Outer Banks after Hurricane Dorian, that's the name, came through, and it did a lot of damage in Ocracoke. But one of the things that captured our executive producer, James's attention, was that they described the water that overwashed the island as almost being like a tsunami. Is there a difference between storm surge that happens really fast and meteotsunamis?
There is. I mean, the big part is with the storm surge, it's usually, in most cases, associated with a buildup of water over time, although, as you know, you can have a fairly rapid rise in water level, but in most cases that's usually associated with fetch and wind driven. So in this particular case, usually the frequency for this meteotsunami wave is usually in a lot shorter period of time, anywhere from 12 minutes to upwards of 2 hours, if you will. And in a lot of cases, you'll just see one wave. There's other cases where you might have a couple of waves that affect a particular area. It all depends on the location that it's being observed at. If you're at an open pier location versus an estuary where you have a little bit of enclosure and you might have a little bit of amplifying effects there. And that's something we've seen in a lot of stations, mainly outside the Carolinas, but that's something you see.
So have there been meteotsunamis caused by tropical systems before, or is it primarily that's what we consider storm surge, and we kind of make a differentiation there?
So the particular analysis that we did, and there was a lot of criteria applied to it, we did some really in-depth statistical analysis and applied different criteria and ruled certain things out. But there were some tropical events that came up in our returns. I believe there was a couple of systems in Florida, but most recently there was a meteotsunami signal that was captured during Hurricane Irma in 2000. 17 that was, just a couple of years ago. So not a ton, but they are there, and again, it just depends on where they're being observed. We have a couple of locations in Florida where the gauges are a little bit more sheltered, like in the area of Port Canaveral, for instance. So that particular basin, you just get a huge amplifying effect there, but it meets the criteria.
That sort of makes me think a little bit about like what kind of really is the core of the cause of this. Is it, now that we've isolated it from storm surge with tropical systems, we want to say, okay, this is storm related. I'm thinking rear inflow jets, right? I'm getting into the signs of a storm where you have a release of energy, maybe a microburst or a downburst of some sort, where the very strong, powerful backwind that generates swell and a small burst into land. And that's kind of what we're getting at, correct?
Yeah, and there's also a lot of, ingredients, if you will, into these. You get the biggest thing is rapid changes in pressure. So you get a major pressure perturbation that also, causes an inverted barometer effect. So that in itself is going to cause a change in water level. But you also need to achieve resonance, and in that case, that's where you have the speed of the storm might be moving at the same speed as the long distance wave, if you will. And if those two sync up, as then they can generate a larger wave, and that's usually what happens in a lot of these cases. So you get a lot of resonance effects. Then, of course, as you move into, as I was mentioning earlier, enclosed estuary areas, you get a very quick amplifying effect, and that in itself will increase the size of a wave. And there are some stations within our network where we see that happen more often, just because of the basin that they're in. So areas like the Long Island Sound, but also Narragansett Bay, and then a couple of areas in Florida, as I mentioned as well.
Understood. Thank you. We do have, I've got something I want to share here, and we talked about instrumentation. So I'm going to bring something up on the screen, something that we use at WeatherFlow, and just let me know whenever you can see. This is all the water stations. These are NOS, NOAA water stations up and down the coast on the Great Lakes, whatnot. And you talked earlier about some of these being in prime areas, more exposed areas for capturing some of this data. If we go down to, say, I'll use Charleston as an example where I live, the station is actually inland inside the harbor, so it wouldn't necessarily catch these meteotsunami events along the outer barrier islands here. But what all's involved with these stations? I'll go ahead and pull one up just for the data. What kind of instrumentation are we talking here? We just have the swell heights and then the sea surface temperatures, or what else is involved with these?
No, so I'm not able, Shay, to see anything that you're showing yet. I don't know if that's my computer or not, but so mainly we're using our tide gauge data to look at this. And in the analysis that we did, we also utilized our meteorological data, primarily wind data and barometric pressure data. But the biggest thing was the water level signal. So we collect data, we put out to the public is usually at 6-minute intervals, but the data is collected at a much higher frequency. We make 1 minute data available for general tsunami monitoring as well. And it's collected and sampled at even a higher rate than that. So we use, I don't know if you're looking for a little more specifics in the type of technology, the types of water level sensors that we're using, or just asking what we're looking at each of the stations.
Yeah, just at each of the stations, like what are you using? Just NOAA water stations, or are we using like some of the USGS stations as well?
For this particular analysis, for this paper and journal article, we wound up using all of our stations and some of the partner stations in the partnerships that we have. So we didn't use any USGS stations in this. Just the NOAA tide gauges. And we used, I have the specific number, but we did 125 tide gauges. And in the 22 years of analysis, we used stations that only had 10 years or more of data, which allowed us to use 125 of them. We have many long-term stations, but we have other ones that are, usually up and running for shorter periods of time. But the water level, we were transitioning our technology from using an acoustic sounding tube, which is still able to see, all sorts of changes in the water level over a short period of time, but it utilizes the speed of sound inside that acoustic well But what we're now transitioning to is microwave radar technology, which is, it's exposed, it's open, but it uses a high frequency radar beam to hit the surface of the water to report back a reading. And again, that's averaged and put into a 6-minute value and then out to the public on the web. So, we wound up using our verified 6-minute water level data. All of our tide data is quality assured on a monthly basis. And, some people might ask, hey, well, you guys collect 1-minute data. Why didn't you use that? We don't actually do as much quality assurance on or generate products out of our 1-minute data, but we were able to get enough returns and signal and confidence just even from our 6-minute data as well. So that was something that was useful. We wind up detiding it and then doing a whole bunch of statistical analysis on it in order to be able to see those signals and those changes.
Thank you very much, Scotty. I'm having trouble getting this unshared, so I'm just gonna stop video. You guys continue on.
Okay, Shay. And so, Chris, monitoring some of our streams that we have going on, this question kind of goes in with what I was going to ask a little bit. A person was asking if I'm out on the beach, would I see one of these coming? So I pose that to you, and also my question. Was there any advanced warning systems in place for this? So, I'm assuming, folks may know what like a big tsunami, if it was moving in, what a big wave looks like. But is there any noticeable that if you're at the actual beach that you could see one of these coming? And is there any advanced warnings? I know you said the Weather Service could be issuing some products and stuff like that.
Yeah, I believe I'll answer the first question first. So it is a good question because, these, at least the events that have been observed here in the States, it's not something that's going to a huge wave like the Japanese tsunami or the Indonesian tsunami that folks might think of as typical examples. So, not rushing in and inundating the land, but it really depends on where you are. If you're on the beach on a day where you have a high surf, you're probably not going to see a meteotsunami unless you have a pretty strong case, if you will, because obviously there you have wave action, wave run up. If you're in a little bit more of a sheltered area and you have a sudden change or a sudden wave moving in, then that's probably something that's going to be a little bit more noticeable. So, in the wintertime when these are happening, not too many people are on the beach, but in the summertime, yeah, it's something to think about. I mean, it's always important to be safe when you're out on the beach. These can be generated from a good distance away. You don't have to have those thunderstorms overhead in a situation in the summertime to have one generated. You can have a storm many miles away that generates one and you get the signal picked up where you are. And that in itself is something to think about. As far as a warning system, there's a lot of cross collaboration right now between the National Ocean Service, the Weather Service, the Office of Atmospheric Research. So there's a lot of collaboration as far as like the research and products and whatnot. But as recently as the past year or two, I have seen some weather service offices in the Northeast and the Mid-Atlantic put out a special weather statement because they saw something in tide data along the coast or even some of the tsunami monitoring buoys, the dark buoys offshore, that led them to feel comfortable to issue an advisory saying, you know what, there may be a sudden change in water level and it's important to tie your boats up and maybe not be on a pier at a particular spot. So some of the wording, it can be ominous, but they do also emphasize that it's different than a storm surge situation where you're not going to have complete inundation.
So, Chris, we've pretty much been talking about the East Coast and the Great Lakes the whole time. Do any of these events happen out west?
They probably do. I will admit, our research, as I mentioned, focused on the East Coast. In my other research, though, prior to this paper, I've been involved in some other stuff. And the West Coast, I have to say, hasn't seen a whole lot. I'm not saying that they don't exist. Obviously, you're not getting the convection along the West Coast that you get along the East Coast. Yeah, you can have some pretty powerful Pacific storms moving in. They don't experience nor'easters, but I think from what I've seen so far, the signals are usually much less frequent on the West Coast. Gulf Coast is a different story. You get a lot of, a lot shallower areas there. You have a much smaller tide range. So when you do see the signal there, it's almost more noticeable than a lot of spots on the East Coast. So that's our goal next, hopefully, is to get involved in looking at wide ranges of the Gulf Coast data to see what we can pull out of there.
Okay, interesting.
And so, Chris, you have this research paper out. What's the next couple of years of research look like for you? What are you working on? What is folks in your office doing about this research, and what do you hope comes from it?
Yeah, so again, we're hoping that we can utilize some of the data from this analysis, the 22 years of data that we looked at, and be able to continue to tweak our analysis to see what sort of other things come out of it, but eventually allow that to be pulled into numerical modeling, hopefully on the Weather Service side, and eventually use a lot of the case studies that were identified or the instances that were identified in our research for the East Coast to be able to sort of build some criteria to develop a more official product from the Weather Service that's utilized, in a wider area. So at the moment, I'm not as involved in those collaborations, but there's a whole lot of talks going on, and certainly building, NOAA as a whole is really building their toolbox as far as really truly understanding these a little bit better. So my personal goal, hopefully, is to get involved in a little bit more research and starting to look at the Gulf Coast next.
Yeah, that would be really interesting to see with the Gulf Coast. I know you've done a lot of research, and we've asked some questions. Anything else that you wanted to hit on tonight? Maybe any topics we haven't discussed about this?
Yeah, I have a couple of stats if you guys are cool with me.
Yeah, definitely.
So the National Water Level Observation Network, all the tide gauges, that we have about 210 gauges around the United States and the U.S. territory. So a lot of these are stations that have been installed for a while. You spoke about the North Carolina ones. Duck's been a long-standing station. Myrtle Beach. Wrightsville Beach has a little bit of a shorter data set. Hatteras, we used to have a station on Hatteras Pier on the outside, but now we have a monitoring station just inside the sound. And stations all the way up, even the Cape Fear River, like Wilmington, certainly a protected area. It's very tidal all the way up to Wilmington. But a sheltered area like that, I think we came back with just one or two events that were verified for Wilmington. So the open coast is certainly the spot where you're going to pick them up most frequently. The Carolina stations averaged generally between 6 and 8 events per year. And, again, with the Carolinas, most active in the winter and the summertime. We did a lot of quality checks, with the events and say, hey, really, what was the weather that was going on? We did some automated stuff using our weather data, but we also did a little bit of a bigger picture with the weather patterns we're looking like. And sure enough, a lot of them were strong thunderstorm events. One question that someone asked recently that was interesting too is, we looked at 22 years worth of data, and someone had asked, were there any correlation to ENSO years, El Nino, La Nina, because obviously that can have effect on the overall weather patterns a lot of times of the year. Looking into that, we did not see any sort of correlation between the average number of events per year and the ENSO status. So there was also no long-term trend between the middle 90s and 2017. That was another thing that came up. Was there any sort of increase in the number of them? And there wasn't.
One question that comes to mind when you're talking about the gauges and stuff is the change in climate and how sea level rise could interact with this. Have you guys done any research on that, or you have any thoughts on that? Could we see possibly more of these situations because of sea level rise, or could we see the waves get higher or larger or anything like that?
I don't think so. I think just because, again, with the frequency band that we're looking at for that signal, again, we de-tided it. We took the tide signal out of the water level data in order to look at it at a much finer resolution. And usually with sea level rise, that's usually longer term data. So in the research that we've done, no. Do I think that that may change or return more signals? I don't think so, just because, again, you're looking at such a smaller scale of time and frequency for these type of events. So, climate change, if it were to affect the number of storms or altering weather patterns, that may increase the number of signals we get. But sea level rise, I don't think would be an influencing factor to seeing more of these.
And I got one more question for you, Chris. I know before the show,
Sure.
I wouldn't throw you a curveball. I kind of changed my mind. I'm going to throw you a little curveball.
Okay.
We're talking Pacific Northwest here, right? Different climate, but they have sneaker waves. What do you know about sneaker waves? Is that something that could be associated with meteotsunamis?
I don't think that they cause them, but I think that can almost be a result of one. So I can't speak too much about that, just because I don't, I haven't looked at enough of the data to be able to tell, because there's a lot of times where these signals are confused with seiching situations and, again, storm surge. But that's a good question. Unfortunately, I don't have much to back it up at the moment, but I'd like to, maybe look at examples of documented sneaker wave instances and say, hey, what were some of the antecedent conditions in the vicinity that led up to those events?
Yeah, they're pretty fascinating. They've actually gotten it down where the National Weather Service in Washington will they've gotten it down to where they can forecast those. So
okay.
Yeah, they can kind of narrow it down. But I know that there's been several instances where people on the beach, giant waves have come up and taken them out into the ocean. With the forecast and lifeguards going out on the beach and warning people, putting the flags up and getting fair warning outs, managed to save a lot of lives over the last few years. Now that more awareness and more research is going into it, so I just wanted to ask.
No, that's a really good point, because a couple other folks on our team that worked on this paper are involved with a little bit more in the way of wave dynamics, but also rip current forecasting, which I'll emphasize is generally different, or it is different than these meteotsunami events. So we got to think of safety all around, though.
Well, Chris, we certainly enjoy you spending some time with us tonight and talking about this. And again, I thought it was really important for folks to know about this, and specifically how the Carolinas play a big role in this. So if folks who are listening tonight on the stream, or if they're going to listen to the podcast later on, if they want to find out any more information, do you have any websites or anything that you could lead them to?
Yeah, I think you can certainly share my contact information offline, but if you go to the National Ocean Services homepage, there's a lot of educational pieces. There's podcasts that they put on there, and there's a lot of educational pieces on there, one-pagers and shorter write-ups. I would put you to our website, tidesandcurrents.noaa.gov. We don't have a ton about meteotsunamis specifically posted on there, but that is the best spot where you can get all of our your up-to-the-minute tides and currents data, as well as our seasonal high tide bulletin that we put out as well. So I'm happy to answer further questions offline, or defer folks if they're looking to see the write-up or the journal article. There's a lot of really cool things in there, and it certainly dives more into the analysis side of what we did to validate these events.
Very cool. We'll definitely send folks that way. And if you want to, we're going to switch gears just a little bit. If you want to stick around, by all means you can, Chris. If you need to jump off, you can do that as well. I'm going to hand it off to Shay right now, and I'll let Shay give us the latest on what's going on in the tropics. Shay.
Thanks so much, guys.
Yeah,
Thanks,
very
Chris.
welcome, Chris. Thank you. I'm going to go ahead and share screen. I'm going to try this again, Sky, and see if that button allows me to unshare at the end. If not, I'll just leave like I did and come right back. Let me go ahead and pull this up. Let me know when you can see. In fact, yep, I see it on the screen now, so I'll be able to stop sharing when it's just done. Just a reminder here that we still are in the hurricane season. It does not end until November the 30th. we are we have now rounded the October 1st date, so we're down in this little area of the tropical season. So still want to sort of caution everybody that the waters are still warm out there. There is still potential for activity to go on. There's been some activity near the Yucatan Peninsula lately that we've been watching, but those have been fizzling out. All tropical waves still merit watching all the way through the season, no matter what. As we get towards the middle of October, we see a decrease in activity as the waters start to cool, and we'll start to see that this weekend, as it looks like, at least for the southeast, Friday may be the last day of real summer heat here. And so we're going to see sea surface temperatures start to drop as a result. Once you start getting down into the 70s, where the water temps are about 80 to 82 right now for most of the Carolinas until you get up to Cape Hatteras, north of Cape Hatteras. Once you start getting down into the 70s, things start to really kind of calm down, and the threats kind of go away for any significantly strengthening systems. They just won't be able to do that over those cooler waters. So we anticipate cooler waters in the near future to help sort of guide this trend downwards, and that's what drives that downwards anyway. So going over to the National Hurricane Center. Whoops, I got off the main page there. Pretty quiet in the tropics overall. This one little area here with a 10% chance near the Yucatan. It's over just south of Cuba, off the western tip of Cuba. We always look at this area right here with a loop current just north of the Yucatan Peninsula. It's a very warm body of water. The Gulf of Mexico, for the most part, is very warm, still very capable of generating strong tropical cyclones in this area. Across the main development region of the Atlantic, continue to watch tropical waves there. So we do anticipate seeing a little bit more activity, but a little bit on the downtrend. So that's kind of what we're hoping. Lorenzo, as of 11 o'clock this morning, this was the last advisory on post-tropical cyclone Lorenzo. It has gone extratropical at this point, and we'll be heading off to the northeast. Still, as a very powerful upper low, this storm is going to be affecting Western Ireland all the way across into England. And so there's, I think the Meteo office over in the UK and Ireland offices are monitoring this storm very closely. A lot of times sometimes they will name storms as they come into Europe. The season starts September the 1st and goes through the 30th of the following year for their storm wind season or windstorm season. So the first name is, I think it's Atia, but this one, once the NHC names it, it's going to keep its name. So it'll just stay Storm Lorenzo all the way through for most intents and purposes for a label. But other than that, things look pretty quiet across the tropical Atlantic basin at this point. So nothing really anticipated the next 5 to 7 days. There's a couple little signals on the medium forecast out, but really not a lot of consistency there either. So I'm going to kick it back to you, Scotty.
Thanks, Shay. And I was noticing Lorenzo forward speed at 40. I think you said 43 miles per hour. That's crazy. That's hauling. yeah.
Once they go extratropical, they get caught up either along a jet stream or along a front of some sort, and they really just tear off towards that area. I mean, the waters below are cold. It's expelled all of its warm features. There's usually, in a baroclinic environment, usually it's dispelling all the warm air out of it. It's going into more of a cooler zone when across the Azores, and it's not too uncommon to see that. It's not rare, but it's not very common to see it. Either way, these storms always pose a threat to European countries simply because of the winds. The wind field is expansive. It's really, really wide as well. So the good thing about it going fast is it'll be over faster. But those winds are going to pack a punch, and the main thing with those is going to be wave heights. Wave heights are going to be, I saw some tweets about 70-foot waves. I'm not sure, maybe if you get to Nazar, Portugal or something like that, where you might see some waves of 50, 60 feet. But I think over the open ocean, there's capable of generating waves to that height. Usually it takes a little bit more of a powerful storm to get to that height, but those estimations may hit dead on in some of the buoy locations. I just, by the time it gets to the coast, those coastlines are made for it. They're built kind of high. And so they're, I wouldn't say they're used to it, but they're pretty resilient when it comes to these big storms. They know how to kind of handle it over in that area.
I know late last week and over the weekend, Lorenzo set some records with being a Category 5, the most for eastward Category 5 on record. So one that really may have not got a lot of publicity just because it wasn't really affected anywhere here in the United States. But Lorenzo itself, pretty substantial hurricane, at least over the weekend. So a little bit closer to home, we're going to do some weather news right now. We've been talking about Lorenzo and the waves that Lorenzo has been producing. A lot of rip current advisories and hazardous beach statements and things issued along the Carolina coastline. Unfortunately, You may have saw earlier on our social media pages, Facebook and Twitter, and you may have heard in the news today, NOAA National Centers of Environmental Prediction meteorologist William LaPente, 58, died Monday after lifeguards pulled him from the surf off the coastal town of Duck, North Carolina. William was one of the head folks at the NCEP, do a lot of modeling data for us. And so our thoughts and prayers go out to William's family, and just these rough seas. It doesn't take much. We've talked about it all summer about rip currents, and unfortunately William got caught up in one, and just learning today that he passed away. So our thoughts and prayers definitely go out to his family from that, just a tragic event. Also in the Carolinas today, you probably experienced the record heat. Over 20 some, they're not all official yet, but at last check, over 20 records broke or tied today in the Carolinas. You can see the map here of all those circled areas. That is from high temperatures. I know Charlotte today topped out at 99 degrees. A lot of other locations, Greenville, Spartanburg, Greensboro, Raleigh, all topping out in the upper 90s. And unfortunately, or fortunately, however you look at it, I like the heat. I think Evan said he's going to miss the heat, but there's going to be one more day of the high temperatures, and then cold front moves into the area, and we'll talk about that in just a minute, and definitely going to bring in some more fall-like temperatures. So again, 99 degrees today in Charlotte. We could rival that tomorrow, maybe even surpass it. It'll all be depending on how sunny it is and if there's any cloud cover in the afternoon. So definitely going to have to watch that heat at least one more day here in the Carolinas. Cool story today out of Charlotte. I think we got some video of a huge dust devil that was in the Charlotte area. We know how there it is. We're looking at dogs, but here's the dust devil. We know how hot it's been and how dry it's been. So just a little bit of wind mixed in. We get this huge dust devil. This was located in Charlotte today. This off Eric Thomas's Facebook page of a construction site there in Eastern Charlotte that saw this huge dust devil. And that's quite impressive, Evan. That's kind of reminiscent of some of the dust devils we saw out in Texas on our storm chase earlier this year. So
yeah, I would say that I got the opportunity to go to Africa a few years ago, and there were a ton of dust devils over there, and even that would have rivaled what we saw in Africa.
Yeah,
dust devils are. I mean, those things, they seem so, they seem harmless, right? Like you never heard of really anything happening, but I've seen a video, and these things can be problematic for parachuters, believe it or not. I saw a video with a Russian gentleman jumping out of an airplane. He landed, his chute got caught in a dust devil, and it really pulled him. It pulled him hundreds of yards. It dragged him pretty hard. So if there's any threat from dust devils, I would say from parachuting for sure. Anything with a kite or a sail-related contraption, I would say just be on the lookout. If you're parachuting, you see dust devil. If you can from where you are, I wouldn't go towards it.
I also say at least once a year, I feel like we see videos of either porta potties or trampolines going flying in these things, and especially with trampolines, that can be a serious issue. And a porta potty on your head wouldn't feel great either.
No.
But a lot of kids on trampolines that are real light, and all of a sudden, if you get tossed, that's a serious issue.
Yeah, and there's those bouncy houses as well if they're not anchored to the surface. So lastly in our weather news, and we'll get the latest update tomorrow, the drought monitor. This was as of last week. The drought monitor came out and is showing a pretty large area of North and South Carolina in some portion of a drought. You can see there on the map lots of moderate drought and severe drought showing up in the Carolinas, especially around the Columbia area. And then you get up into that moderate drought and abnormally dry conditions up into the North Carolina area. And so we're looking for some rain. Unfortunately, there's not a lot in the forecast, even though there is some cooler temperatures. Shay, you alluded to the Southeast seeing kind of the last gasp of summer heat. I know you guys, even at the coast, are looking for the temperatures to start changing as well. What do you have on that for us?
Yeah, I was going to share screen. I'm not sure if James is working his magic in the background, but yeah, we're looking to have our last real hot day on Friday, and I'll just give a quick share here on this and give it right back to you. But you can see the temperatures here. This is for the Charleston International Airport, our official gauge, and for Friday, I mean, this 97 might be a little bit far fetched for tomorrow. This is the GFS ensemble, more like 93 to 95, but either way, this heat is going away. We have one more little warm day on Monday, and then we cool down. So we're looking at 70s and 80s for highs pretty much. And I've looked at the medium term and the long term forecast maps, and it doesn't look like this heat is coming back anytime soon. So a big, sigh of relief for a lot of folks here. We're ready for it to go. The mosquitoes are out, the humidity's up. It's like, almost October, right? You could say, and you play with the words a little bit, but it looks like we're starting to transition into our typical weather that we should be seeing for this time of the year versus breaking high temperatures, which we don't want to do that anymore. So yeah, man, looking good here, Scotty.
Yeah, we're going to see that backdoor cold front move through the Raleigh, Greensboro areas before it moves in to more of the Midlands of South Carolina and the Piedmont of North Carolina. So that'll move through on Friday. And when you wake up on Saturday, you'll notice, I'm going to say, a chill compared to the temperatures we saw today, close to 100. We're going to be closer to 70 on a Saturday. So it's going to noticeably be a cooler day, and we stay cool through the weekend. There's a storm system that could pass through late Monday night into Tuesday. It could bring us some passing showers, but again, no major rain threat, really, unfortunately, posing for the Carolinas. And we had our hopes up a few days ago, and now as we get closer to the event, it looks like it's still a little bit up in the air, but it looks like we may not see as much widespread rain as we first thought. So, and one thing, Evan, that we were talking about before the show started, this time a couple of years ago, I think it was 8 years ago, we saw snowfall up in the mountains on October 1st, and now we're talking about record heat. So definitely October can be a trying time here in the Carolinas.
Oh yeah, I mean, I love the month of October. I love northwest flows, and I think snow and highwind events are amazing. As you also said, I will miss a bit of the heat and beach weather here in Charleston. But I know for the folks back in Western North Carolina, they're ready for a break from this pattern, as well as almost everyone across the Carolinas. On October 1st, Asheville had a high of 90 degrees. That was the first ever 90-degree day in October, and the period of record dating back to 1956, I believe. And that's a record monthly temperature. And then today, they broke the record that's only one day old and recorded a high of 91. So we set two monthly record high temperatures back to back. And I don't think it's impossible that we do it again tomorrow. So, Scotty, like you said, we were kind of crossing our fingers and hoping for rain next Monday, but it's not looking quite as good as it was. We did have some plentiful rain. I'm going to say it was on Saturday or Sunday, sometime over the weekend, that a few inches or a few locations recorded half an inch to anywhere upwards of 2.5 inches. But man, we need the rain. We need the rain so bad. We've had some fires breaking out in Catawba County. As I think they've said they've responded to 7 fires over the last week in Western North Carolina. So it's starting to get bone dry.
Yeah, definitely. I think there's some burning bans out for some portions of Tennessee as well. Definitely need some widespread rain. I know there's been, like Evan talked about, some localized storms, but this event, you need some of those widespread rains and those slow soaking rains to kind of really start to eat away at some of this drought. But unfortunately, it doesn't look that way. And these hot temperatures are also delaying the leaf changing season. So hopefully these cooler temperatures will help start that process, and we can get some leaves changing before Evan talks about those northwest cold fronts moving through, bringing those higher winds, blowing the leaves off. So it's been
we all know what Evan's waiting for here. He's balling his hands up. He's ready for the northwest flow and the Ohio Valley short waves. We know what's coming.
Yep. You will see, once that starts setting in, you'll see it all over our Twitter page, because it will be nothing but webcams and wind reports and satellite feeds.
Yeah. So it's becoming we're beginning to get into that change of season where we go from worrying about tornadoes and severe weather to more snow and wind. So it's that season, and it's October 1st. That means in 1 month my Christmas tree goes up. So we all know it's beginning to look a little bit more like fall and winter around here. So anyways, enough rambling for tonight. We appreciate you joining us tonight. Go check out our show from last week. We'll say this, that show that we did last week with Eric Thomas, Brad Panovich about the radar hole was the highest most watched show that we've ever produced here on Carolina Weather Group. So thank you for checking that out. And if you've not seen it, we ask you to go watch it or listen to it on our podcast. And also, while you're on the podcast, you can type in Carolina Weather Group on any of those major platforms, and you'll pull us up, and you'll be able to listen to our 30th anniversary Hurricane Hugo special as well that we were able to do a couple weeks ago. So go check those out. As always, we ask you to subscribe. Let us know how we're doing. Give us a review. And you can also submit some particular topics or guests you would like for us to bring on the show, and we'll work on that as well. So we would definitely appreciate that. So until next Wednesday night, we hope you have a great weekend. Enjoy the last day of the heat, and then enjoy the cool weather over the weekend. And we'll see you back here next Wednesday night for another edition of the Carolina Weather Group.